Welcome to the DIY Honda Garage channel. The diagnostic trouble code B18A7 specifies a voltage input issue with the left BSI radar unit in the Honda Odyssey model years 2011 to 2017. The BSI, or Blind Spot Information System, is designed to help detect vehicles in the driver's blind spots through radar technology. The left BSI radar unit specifically contributes to monitoring the left side of the vehicle, enhancing safety during lane changes or merging. When the voltage input to the radar unit is low, it can lead to insufficient readings and potential failure of the blind spot monitoring feature. This code could indicate a fault in the radar unit itself, issues with wiring, or connection problems. The effective diagnosis is essential for restoring the proper functionality of the safety systems in the vehicle. The B18A7 error relates directly to the left blind spot information, BSI, radar unit. This unit is a critical component that assists in detecting vehicles adjacent to the Honda Odyssey, thereby contributing to enhanced safety during driving maneuvers like lane changes. It functions by emitting radar waves to the side and rear of the vehicle to monitor for obstructions in the blind spot. The BSI radar unit is typically located near the driver's side rear bumper, making it subject to dirt and debris accumulation, as well as potential impact. When the signal received by the vehicle's computer indicates low voltage, it highlights a malfunction that could stem from the unit itself or its associated connections and wiring. Proper functioning of the radar unit is paramount to ensure the reliability of the vehicle's safety systems. The B18A7 code can stem from several potential causes. One common issue is poor connections, which can arise from corrosion, dirt, or physical damage to the connectors at the BSI radar unit. Such issues hinder the electrical signals necessary for the radar unit to function correctly. Another possibility is a defective radar unit, which can arise due to internal failures or manufacturing defects. Open wiring is also a prevalent cause. It can occur due to wear, damage, or disconnection of wires linking the radar unit to the vehicle's electrical system. Each of these issues necessitates thorough inspection to identify and correct the root cause of the low voltage input. There are several symptoms linked with the B18A7 diagnostic trouble code. Firstly, drivers may notice warning indicators illuminated on the dashboard, signaling an issue with the blind spot monitoring system. This indicator serves as an alert that attention is required. Another common symptom is the failure of the blind spot monitoring features, which may not give any alerts when vehicles are present in adjacent lanes. Additionally, a malfunctioning left BSI radar unit may render the radar features of the vehicle unresponsive, leading to an increased risk of collisions due to unseen vehicles in the driver's blind spot. Understanding these symptoms is vital for timely diagnosis and repair. The first step in troubleshooting DTC B18A7 involves utilizing the Honda Diagnostics System, HDS, to clear any existing diagnostic trouble codes. Clearing codes is essential as it resets the vehicle's modules and provides a fresh diagnostic baseline. After clearing, it allows for an accurate assessment of the system's current state. Once the codes are cleared, it is important to turn the ignition switch to the on-to position and wait for a minimum of 20 seconds. This time provides the necessary opportunity for the vehicle's systems to undergo their self-checks, potentially revealing new faults. If DTC B18A7 reappears during this diagnosis, it indicates an ongoing issue requiring further attention. The second step in the troubleshooting process is to check for DTCs once more using the Honda Diagnostic System. This action is crucial after the initial clearing of codes, helping to ascertain whether DTC B18A7 has reappeared. If the DTC is still indicated on the system, it signals that an underlying issue needs to be addressed. Conversely, if the DTC is not present, it may imply that the original fault was intermittent. However, it is wise to check for loose or poor connections in the wiring harness and connectors associated with the left BSI radar unit, as intermittent failures can still occur without triggering a continuous diagnostic trouble code. In Step 3 of the troubleshooting procedure, it's necessary to turn the ignition switch to the lock 0 position for safety and access. Afterward, the next critical task is to check the connection at the left BSI radar unit's 6-pin 6P connector. This location is important as a faulty or loose connection can significantly affect the radar unit's performance. Inspecting this connection involves looking for signs of physical damage, corrosion, or any foreign material that might disrupt data transmission. Establishing whether the connection is stable and secure is pivotal as it determines whether to proceed to further steps in the diagnostic process. Step 4 requires confirming whether the connection at the left BSI radar unit's 6P connector is okay. If the connection is secure and undamaged, the troubleshooting process proceeds to the next step, where the radar unit will be disconnected for further testing. However, if a poor connection is discovered, the integral step is to repair this issue and retest the radar unit's functionality. A strong and intact connection is essential for the BSI system to receive proper voltage and communicate effectively with the vehicle's onboard computer. Following proper procedures ensures the integrity of the electrical system, thereby facilitating accurate diagnostics of the radar unit. In this step, the technician will need to disconnect the left BSI radar unit's 6P connector, ensuring safety is a priority while performing this action. Once the connector is detached, the ignition switch must be turned back to the on-to position. This process of disconnection and ignition activation will allow for the testing of voltage to determine the operational state of the radar unit. Monitoring voltage is critical, as it provides insight into whether the radar unit is receiving adequate power to perform its functions. Care must be taken to ensure the testing equipment is correctly attached to measure the voltage at the connector terminals accurately. At this stage, the technician should measure the voltage at the left BSI radar unit's 6P connector, specifically between terminals number 2 and number 5. Terminal number 2 receives the ignition voltage, often identified by a light green wire, and terminal number 5 is the ground terminal connected to the vehicle's electrical system. An appropriate tool, like a multimeter, should be used for accurate voltage readings. Checking this voltage is essential, as it establishes whether the radar unit is receiving sufficient battery voltage. If the measurements reveal battery voltage present, the next step is to replace the left BSI radar unit, as this might indicate internal failure. However, if no voltage is detected, the technician will need to continue to Step 9. Upon determining that there is no battery voltage in the previous measurements, Step 7 requires the technician to measure the voltage between terminal number 2 of the left BSI radar unit's 6P connector and body ground. This step is crucial to ascertain whether an open circuit exists in the wiring harness. If the voltage exists between terminal number 2 and the vehicle's ground, this indicates a problem within the wiring between the left BSI radar unit and the ground point. If voltage isn't present, the technician must pinpoint where the open circuit may be, likely indicating issues in the wiring connecting to the radar unit from the rear fuse box. A systematic approach in checking both areas will facilitate identifying the exact cause of the issue. Should the reading show battery voltage when measured from terminal number 2 to body ground, the next step is to repair any identified open circuits in the wiring, leading from the left BSI radar unit's 6P connector to the ground reference point, usually denoted as G802. Open circuits can undermine the integrity of the electrical system, preventing voltage from reaching critical components. Identifying breaks or disconnections in the wire must be done thoroughly. A proper repair ensures the continued performance of the blind spot detection system. After wiring repairs are completed, conduct further tests to confirm that the functionality has resumed effectively and the DTC does not reappear. If, however, the voltage check reveals insufficient power from the radar unit's terminal number 2 to body ground, the technician should then focus on the wiring from the rear fuse box to the left BSI radar unit. This area is prone to faults that can stem from wear, disconnection, or damage due to road conditions. A detailed inspection of the wiring is necessary, and any identified issues need to be rectified. By repairing any open circuits or broken wires within this pathway, the connection between the fuse box and the radar unit can be restored. After completing these repairs, it is important to retest the system to ensure functionality is restored and confirm that no further diagnostic trouble codes exist. Once the necessary repairs are executed, the final verification process is critical to confirm that the issue has been appropriately addressed. Start by clearing any remaining diagnostic trouble codes using the Honda Diagnostics system. Following this clearance, run a series of tests on the blind spot monitoring features of the Honda Odyssey. This testing will help confirm that adequate power is being delivered and that system diagnostics indicate no further issues. It's essential to verify that warning indicators are no longer illuminated on the dashboard. Through this comprehensive testing, a technician can ensure that the blind spot detection system is functioning reliably and providing the expected safety support while driving. Preventive maintenance is key in ensuring the continuous operation of the left BSI radar unit and the entire blind spot monitoring system. Regular visual inspections of connections and wiring can help to catch issues before they escalate into significant failures. Cleaning any buildup of dirt or corrosion from the radar unit's connectors is equally important, as it helps maintain strong electrical contact. Additionally, ensuring that the radar unit is free from physical obstructions or damage is vital for optimal performance. Implementing these maintenance practices will enhance the reliability of the system and prolong the lifespan of the radar unit and its components, safeguarding the driver's experience on the road. In conclusion, the DTC B18A7 signifies a low-voltage input issue with the left BSI radar unit in the Honda Odyssey. Understanding the components involved and their functionality is critical for diagnosing and resolving the issue properly. Following the specified troubleshooting steps can assist technicians in pinpointing the root cause, whether it be poor connections, defective high-tech sensors, or wiring problems. Once repairs are executed, verifying the effectiveness of these actions is essential for safe operation. Implementing preventive maintenance will contribute to the longevity and reliability of the blind spot monitoring system, keeping both the driver and passengers safer during travels. Staying proactive in vehicle care can prevent future DTC occurrences and enhance overall vehicular safety. Please like and subscribe to the channel. See you next time.